Hello and welcome back to the course Students Guide to Information Theory and Coding. In this session, we will understand the concepts of channel encoding techniques. So a brief overview of this session is we will first try to understand the block schematic of digital communication system where the importance of the channel encoding block or a quick summary of all the blocks that we have learned under a digital communication system block diagram. Then why we need a channel encoder. So we'll discuss in very much detail the necessity of channel encoder in the digital communication system block schematic. And then we will try to understand some fundamentals of channel encoding technique. We'll take a quick summary of different types of channel encoding technique. And in the end, some applications of the channel encoding technique that we'll discuss in detail. So up till this point, we have understood some of the block schematic that we have discussed at the initial part of this particular course through the block diagram of digital communication system. The digital communication system has basic four blocks. The first block is the information source. Second block is the source encoder, which maybe consist of the sampling and the quantization process together, but we call it as a source encoder. Third block is channel encoder. Fourth block is CW modulator, that is continuous wave modulation, and a signal is then being transmitted to communication channel. So this particular diagram we have considered for the study of communication system. Block number 2 and block number 4 you have already learned in digital communication, and block number 1 and block number 3 we are interested to learn in information theory and coding technique. So out of that, in unit number 1, our focus was on understanding the information source by understanding the basic concepts of information theory, the terms such as amount of information, entropy, average amount of information, that is entropy, information rate, and then the calculation of variety of entropies as far as the communication channel is concerned. So that is all we considered in unit number 1 and in the initial part of unit number 2. Also, we have covered some of the waveform coding techniques or source encoding techniques in unit number 1, which belongs to variable length coding technique like Shannon-Fano code, Huffman code, and then the fixed length coding technique like Lempel-Ziv or Lempel-Ziv-Welch code that we have understood about source encoder. Now, in this unit and for the next 3 to 4 units, our focus will be on only one block, that is the channel encoder. So we will try to understand what is the importance of this particular block, why these 3 or 4 units are totally dedicated to this particular block, and basically what is the purpose of this particular block, channel encoder, in the digital communication system. So let us begin understanding the concepts of channel coding techniques. Now, why we need channel code encoder? As usual, any topic which we want to learn, our first question to that particular topic is why we require this channel encoder. Now, the answer to this particular question is, I can give it in 2 lines, that 2 things I would like to carry out at the receiver end. First, to detect the error in the signal, and second, to correct the error in the signal. Now we understood that whenever we transmit a data from the transmitter, so this is your transmitter, you are going to generate certain data from the transmitter, and this data is being transmitted along the channel. We know that the channel is the additive channel, and which is going to add certain amount of noise in my data, and this noise is going to corrupt my data at the input of the receiver. So this will be straightway given at the input of the receiver, and here I got a corrupted data. So in simple case, suppose I am transmitting certain data like 1, 0, 1 0 1 1 like a digital data. Because of the noise, this digital data will get corrupted, or it may have certain error that I'm transmitting 101011, but the received data is 111011. And here I come to know that there is an error in one particular bit, that is second bit, where I have transmitted 0 but I'm going to receive 1. So this is called as the data which is received with certain error. Now, if I'm at the receiver end, I do not understand that the received data 111011 is having any error or not, because I do not know what is the data transmitted by the transmitter. If I know what is the data transmitted by the transmitter, I will compare bit by bit these two data, and then only I will come to know that there is an error in the second bit. So channel encoding techniques, they are going to give me the facility for detection of the error in the signal, that the received signal has error, yes or no. And if you are able to detect out the error, they will also give you the facility to correct out this particular error. Now, how to correct out this error? There are certain methods, channel encoding techniques, which will help me to identify that the error is present at the second bit. And if I come to know that the error is present at second bit, I can simply invert that bit so that I could able to get the corrected signal at the receiver. So the techniques, the encoding techniques which can give me the facility for detection of the error as well as the correction of the error, they are referred as channel encoding techniques. So the simple question comes, why I require channel encoder block in the digital communication system? The simple answer to this question is that it will give me the facility of error detection and error correction at the receiver end. That is what the channel encoding technique. Now, one very basic channel encoding technique you have already learned in your earlier classes, like in digital electronics or even in the study of the binary systems. You have understood the parity check code. I hope you remember the concept of parity check code. What is the parity check code? Generally, you have a data, right? A data of say 7 bit 110110 and 1. This is 7 bit data. And suppose I'm implementing the concept of even parity, right? Even parity that I'm going to implement. So in even parity, I'll count the number of ones. Number of ones here are 1, 2, 3, 4, 5. They are odd. So to make it even, I add one more 1 over here, and this is called as the parity bit that I have added, so that the parity will get even parity. Now, suppose this data I have transmitted from the transmitter to receiver, and at the receiver I have received the data 1 1 1 this is also 1 1 1 0 and 1. What I will look at to this particular data, last 7 bits, I observe that 1 2 3 4 5 6, there are 6 number of ones, that is they are even, but still my parity bit is 1. It means that the even parity is not been followed, and I can take a decision that certain amount of error is present in my signal, right? So this is called as the error detection by using even parity data transmission. Similarly, I can use odd parity, but this even or odd parity can able to give me the facility of error detection only, because looking at to this, I am not able to understand which particular bit is in error at the receiver. So this is a simple example of channel encoding technique by using parity check code or parity check encoder. So this is why we need channel encoder. So the simplest answer why we need channel encoder, because it will give me the facility to detect the error and to correct the error in the signal. Now, let us try to understand few more aspects of channel encoding technique. What are channel encoding technique? I can classify them into two broad areas. One area is called as waveform coding and second area is called as structured redundancy code. Now, what is waveform coding? Waveform coding you have already learned in digital communication. What is waveform coding? Waveform coding is simply CW modulation technique. CW modulation technique or continuous wave modulation technique, and this continuous wave modulation technique you have already learned. Variety of techniques you have learned. The technique called as BPSK, the technique which is called as BPSK, QPSK, Amory PSK, right? These are all ASK, PSK and FSK. These techniques you have already learned, right? ASK, amplitude shift king, PSK, phase shift king, FSK, frequency shift king, and all its variety of versions that you have understood, that you have learned in digital communication. They belongs to the category of waveform coding. The second type of channel encoding technique which we would like to understand in this particular subject, it is called as structured redundancy code. So it's a code. Code means binary data in which the redundant data means the data which is not much useful for me, which does not contain any information, that is called as redundant data. That redundant data I'm adding into my information data in a structured way. That's why it is called as structured redundancy code. Let us try to understand how we can generate this structured redundancy code. So, how the structured redundancy code can be implemented with error detection and retransmission and forward. There are two ways with which I can generate this structured redundancy code. One is called as error detection and retransmission, and second is called as forward error correction. Now, in the simplest way, if I would like to explain error detection and retransmission, I'll take once again the example of transmitter transmitting certain data towards receiver, and here I am going to get certain received data. This is the transmitted data, this is the received data. If I could able to take the decision that the error is present in my system, my received signal, I will request the transmitter, I have received the error, please retransmit it, and the transmitter will retransmit it. It is like that I am taking a feedback in my class. Do you understood? You say yes. It means the data has been received correctly. If you say no, then I am retransmitting that particular data. So that's why error detection and retransmission. If you detect the error, request the transmitter to retransmit. Transmitter will do the retransmission and you could able to get the corrected data. Second case, forward error correction. Here, there is no process of retransmission, right? Like that, what is happening nowadays in online lecture, right? You are not giving any feedback to me, so I am simply doing forward transmission. Forward transmission means transmitter is transmitting towards a receiver. Transmitter does not bother what the receiver is going to receive. He is not at all interested in understanding what receiver is going to receive. Now, it's a complete task, complete job of the receiver for detection of the error as well as correction of the error. But for that purpose, at the transmitter end, we have included the block called as channel encoder. This channel encoder will give the facility to the receiver to detect and correct a particular type of error. But transmitter will do the inclusion of this channel encoding technique, inclusion of the structured redundancy, and will simply throw it toward the receiver. It's a job of receiver to detect the error as well as to correct the error. That technique is called as forward error correction. So, in short, channel coding techniques, I can classify them as waveform coding and structure redundancy code. Structure redundancy codes are further classified as error detection and retransmission and forward error correction. Let us try to understand them in more detail. But prior to that, we have few things like in channel coding, signal processing operation we are doing where reliable transmission is expected, and for that purpose we are adding redundant symbols, that is called as structure redundancy. Objective is error detection and correction. So error detection without correction or error detection with correction, these two way we can classify channel coding technique. So as I mentioned, channel coding techniques are classified into two categories: forward error correction called as FEC and automatic repeat request called as ARQ. If I try to compare them, forward error correction, it uses simplex channel because transmitter does not bother any feedback from the receiver. So simplex channel is suitable. But for automatic repeat request, you have to give a request for retransmission. I required a duplex channel over there. Care is taken to correct at the receiver, request retransmission of erroneous data. Bandwidth required is very less for forward error correction, but here very high bandwidth is required because you have to you require some bandwidth for forward transmission, some bandwidth for backward feedback, and that's why the bandwidth requirement will be more for this automatic repeat request. So two fundamental characterization: forward error correction, automatic repeat request. Now further, automatic repeat request will come into two flavors. First is called as stop and wait. Second is called as continuous ARQ. And in continuous ARQ, there are two techniques: go back N and select to repeat. One by one, we will try to understand all these techniques in detail, how the things have been carried out. So this is just one aspect of automatic repeat request. But as it required a duplex channel and it requires a very high bandwidth, our more and more focus will be in understanding the forward error correction technique, that is FEC, channel encoding techniques, which are classified into two broad categories: block code and convolution code. Block code we will try to understand in unit number 2, and convolution codes we will try to understand in unit number 5. Block codes are further classified as linear block code and non-linear block code. Linear block code is further classified as cyclic code and non-cyclic code, and cyclic code are further classified as BCH, that is Bose-Chaudhary and Hackingham code, and a Golay code, and BCH is further classified as binary BCH and Reed-Solomon code. So second unit is focusing on block code, third unit is focusing on cyclic code, unit number 4th is focusing on BCH and Reed-Solomon code, and unit number 5 you will be learning convolution codes. So if I look at the syllabus of next 3 units, we have all types of forward error correction code that we are going to learn: block code, linear block code, in which cyclic code, in cyclic code BCH code and Reed-Solomon code, and finally convolution code. And in the same unit, for second unit, we are also understanding how automatic repeat request works. So this is what the overview of different types of channel coding techniques which we would like to understand in this particular subject. Now, what are the applications of error control coding? Which particular error control technique is used in which particular application? That also we would like to understand, but this is just a general summary of where the error control coding is applicable. Whenever the first application is in CD player, whenever you write a data on your compact disc, and if you want to write and reproduce that particular data without error, we generally use Reed-Solomon code in the applications of CD player. In normal computers, for data storage and retrieval, we understand that we stored a data and we would like to retrieve it. While retrieving, your data may happen, there may happen certain error. If you want to remove out that error and you want to do the error detection and correction, you may use the convolution codes or block codes over here. In the applications of digital audio and video system transmission, in aerospace application, in mobile cellular telephony, enhancing security in the banking application, we can use error control coding techniques. So in short, whatever the digital data that you transmit on whatever the type of communication system, error control coding or the channel encoding techniques are integral part of that particular transmission, and any one of the technique which is mentioned over here is definitely used in the data transmission. You might have heard that whenever you transmit a data from one PC to another PC, you have used CRC encoding, that is cyclic redundancy code encoding. And most of the times in networking, you may come across this particular CRC term. So still in practical, we use CRC coding. BCH and RS are very famous encoding technique in most of the digital data transmission. Convolution code is still used. So all the techniques what we are going to learn, they are still practically used in the digital communication system, and our purpose is to understand all these encoding techniques in detail in the theory part and their assignments in the practical session, how we can write a code for block code, for a convolution code, or for a cyclic code or BCH code, that we'll try to understand in the practical session. So this is the summary about channel coding techniques. I try to answer the basic question why we required channel encoder, where is the channel encoder present in the digital communication block system. It is block number 3. Why we required channel encoder? Because it will give me the facility for error detection and error correction. Types of channel encoding technique, their basic classification, forward error correction, automatic repeat request, and further classification we try to understand in this session. From the next lecture, we will try to understand each and every technique starting from automatic repeat request to block code in unit number 2, and we'll try to understand how we can design the code word of this block code or the convolution code under the forward error correction. So I think that's all from my side. If you have any doubt, you may ask.